Welcome back. Everything you've computed so far, sigma, capability, DPMO, assumed one thing, that your measurements are true. Today we audit that assumption. Gage R&R asks how much of the variation you see comes from the parts and how much from the measurement system itself. Both exams test it, every audit demands it, and skipping it is how teams spend months fixing a process when the gauge was the problem. We'll design a study, then run one live in the LeanProjax platform. Let's measure the measurer. Split the variation you observe into two rivers. Part-to-part variation is the real differences between parts, the signal. Measurement system variation is the noise, and it has two tributaries. Repeatability, equipment variation, EV, same operator, same part, same gauge, different result, the gauge trembles. Reproducibility, appraiser variation, AV. Different operators get different answers on the same part. The people disagree. R&R combines both, and the whole game is, how big is that noise compared to what you're trying to see? The study is a designed experiment. Take parts spanning the real process range. The textbook study is 10 parts, 3 operators, 2 trials. The practical minimum is 2 operators, 2 trials, balanced cells. Randomize the measurement order and keep operators blind to part identity and to their own earlier readings. Each operator measures every part, every trial. That grid is what lets the math separate gauge trembling from operator disagreement. 4 numbers come out: %GRR against total study variation, under 10%, acceptable, 10 to 30, marginal, judgment call, over 30, unacceptable, fix the measurement system before touching the process. NDC, the number of distinct categories the gauge can resolve. 5 or more, or the gauge can't tell your parts apart. %P over T compares the noise to the tolerance instead. Can the gauge police the spec? And the EV versus AV split tells you who to blame, the equipment or the people. Let's run one. I'll use the LeanProjax platform. In the toolkit, I create a new Gage R&R study and paste the readings. 5 parts, 2 operators, 2 trials, 20 measurements. Save, and the analysis lands %GRR 8%, under 10, acceptable. NDC over 17. The gauge easily tells parts apart. But look at the split. Equipment variation 3.5%, appraiser variation 7.2. The operators disagree more than the gauge trembles. And with the tolerance set to 20, %P over T reads 12.7. Verdict: trust the gauge, but align the operators. Now act like a greenbelt. High EV. The equipment is the problem. Maintain, fixture, or replace the gauge. High AV. The people disagree. That's a method problem. Train, write the operational definition, standardize the technique. Marginal 10 to 30 results. Decide by criticality and cost. A marginal gauge on a safety-critical feature is not acceptable. And the golden gate: never run a capability study or an improvement project through a measurement system that failed its R&R. Fix the ruler first. Exam drill. 2 questions. Question 1. Your study returns %GRR of 25%, mostly appraiser variation. Classify the system and name the first fix. Pause here if you need a moment. Marginal. And since AV dominates, fix the method. Operator training and a tighter operational definition, not a new gauge. Question 2. NDC comes back at 3. What does that mean for your data? Take a few seconds. The gauge can only resolve about 3 distinct groups of parts. Below the 5 minimum, part-to-part differences are blurred by measurement noise. The ruler is audited. Now you can trust what it tells you. Next lesson is the measure capstone. We assemble the whole phase. Data collection plan to baseline capability on the live project. Tollgate ready. Subscribe and I'll see you there.